Neil Alexander, you're the principal consultant at Bucephalus Consulting, and you're joining me from Canada today?
Hi there. Yes, just very shortly north of the USA. I'm on the banks of Lake Erie, and I can wave at America from where I am.
And do you visit the US often if you're so close?
Uh, Not as much as I'd like. That border is a little bit harder to get over nowadays than it used to be, and so that kind of adds to the journey.
Yeah, but you've been in Canada for a while now, right? Are you from there originally?
No, I'm. You can probably gather from the accent that I came here from England, and I came here probably about 20 years ago, I guess now. So,
What brought you to Canada?
well, originally I was told to come here. The company I worked for at the time, AEA Technology, had bought a small radioactive waste management company in Canada, and I was involved in buying it. And while I was here, they said, "And by the way, you're running it."
Yeah.
So that was a bit of a shock to me, given that I lived somewhere else. But that originally brought me out here. I then have to say I made the what they used to call the $10,000 mistake. I think it's a bigger mistake than that now. And at the end of my contract, I went home and then realized that I love Canada a lot, and had to turn that decision around and come back out here.
Oh,
So
that's a great story.
it's not that I'm not the only person that's done that.
Yeah. And so let's start at the beginning of your career. So you got a PhD, and you studied the effects of radiation on steel, right?
That's correct. Yes. So I have to say that was my introduction to the nuclear industry. But at the time, I was just an avid metallurgist or a metallurgist. I can never remember which one I am on this side of the Atlantic. A material scientist, I think, is what I say nowadays. I was an avid material scientist. That was what interested me. The fact that I was doing the work for the nuclear industry was something I barely noticed until I came back to the nuclear industry many years later.
So what gets you interested in metallurgy? I can't pronounce it
Exactly.
very well.
Material science. Let's agree on material science. I don't know. It's just one of the things that happens to you, isn't it? I suddenly became passionate about dislocation loops and my ability to study them with electron microscopes. If I had to try and explain to you why now, I think I would probably find that impossible. But it all made sense to me at the time.
Yeah, you just followed your heart, I guess, and you
I
found
did
your path.
indeed. Yeah, indeed.
And so what do you do after your PhD?
Well, then I went and did something completely different, but in the end, something very useful. I went and joined something called the Energy Technology Support Unit, which had actually been created in the United Kingdom by the government, because at the time we were worried about running out of coal.
Hmm.
And so they were looking at ways of using renewable energies in order to avoid using coal, not for any greenhouse gas reasons. We hadn't, I don't think, even imagined the issues. I certainly don't remember greenhouse gas being on the agenda at the time, but simply because we thought we were running out of coal. And it looked at renewable energies and energy efficiency. And so I spent a year and a half in each of those fields, before then moving into a more commercial aspect of the company and becoming involved with nuclear and nuclear power.
And so when you say renewables, what sort of renewables were you working on? What was big and emerging at the time?
So the group was looking at everything, at tidal power, wind power, solar power. I actually was involved with using waste as fuel, and had actually a very interesting summer where an organization we were working with were producing waste as fuel pellets. And I
Hmm.
went around to all the major coal customers saying you could use these pellets, and negotiated a price for it. And I was followed around during the whole summer by someone from the coal industry who then renegotiated the price after I had left. So I did a good job for industry by lowering the price of coal. I
Yeah.
didn't do much to offset its use, though, unfortunately.
And what were the prices like at that time?
Oh, heavens no. It was very, very cheap because it was in money of those days and it was a long, long time ago. So
Right.
I honestly don't remember.
Not in a numerical sense, but
No, no.
were the pellets able to be used in existing coal plants, or would they have needed new plants?
Well, that was the problem. We were very much in a research and development phase, trying to get them trialed in practice to see what the issues were, and there were some problems. So clearly, to use fuel in that way, to use waste in that way as a fuel, was going to be a challenge. And it turned out that it was better just to take it to a dedicated plant and burn it directly, rather than to make it in the pellets, into the pellets.
And so then you said you got into the nuclear industry after this position. How did you transition from renewables to nuclear?
Well, I'd like to say it was a deliberate decision, but actually it was just one of those things. I was tapped on the shoulder and said that I showed opportunity to assist in the commercial operations of the organization I was with. It was actually what used to be the United Kingdom Atomic Energy Authority. It was becoming AEA technology and going through privatization. So they were looking for people that showed a commercial aptitude, and they put their hand on my shoulder, put me through a training course, and then I ended up in the nuclear part of the business purely by accident.
And what was their decision to switch from government centered to more privatized commercial?
I'm not sure it was their decision. It was a government decision. That the United Kingdom Atomic Energy Authority had been government owned. They could see a great deal of opportunity within the organization for it to do work, not just nuclear work, but in a whole load of other fields, and wanted to stop or reduce the amount of funding that it was providing, and to see the organization produce more income for itself.
Mm. And did the switch to privatization change their nuclear sector at all? Did it help it? Did it hurt it?
I don't think it made a difference in that area. It was not a very successful switch from a government organization to privatization, but the nuclear industry was changing separately at that time, and I don't think what happened within AEA technology really made that much difference to it.
What was causing the industry to change so much at that time?
Well, it was morphing. The United Kingdom had been very involved in the development of early reactors. It had developed the Magnox reactors and the advanced gas-cooled reactors, and they were out there and operating. It had then gone into reprocessing, and UKAEA had been very involved in the reprocessing program. But all of that equipment had been developed, installed, and was now operating. And so the research side of the the operation was changing just naturally through its life cycle.
And it sounds like, in terms of your professional career, you were changing as well, right? Because you went from someone studying radiation in your PhD to getting trained to work on privatizing a sector of a company. So how did you deal with that learning curve and really try to develop your skills and to be more of sales and communications and marketing?
I think that's something that just is natural with some people. I get on well with people. I have a philosophy that a good sale is providing to a customer something that they want. And so it's largely an activity of listening to what people want, fitting it with what you can deliver, and making sure that you deliver what you want when you've sold it to them. So with that philosophy, things become quite easy.
Yeah. So you were at AEA for how long, and sort of what was your day-to-day like in that role?
Oh, well, My career has been an interesting one, and I think it's sort of characterized by the fact that if there's a challenge that nobody else wants to take up, they tended to give it to me. So I moved around from one field to another, making changes to things. So AA technology was wonderful to me because I spent some time in decommissioning and waste management for the conventional nuclear industry, largely trying to make sales to the US. So I spent a lot of time flying around the United States, carrying my skis with me wherever I went, and normally finding somewhere curious to ski at the weekend, including, I think, Wisconsin was one of my highlights. And but then I went on and I did things like for a while I was in radioisotope production, producing yttrium-90 for the medical business, and then ended up doing a lot of work in dealing with radioactive materials from outside of the nuclear industry, where I gained an appreciation of just how much modern society relies on radioactive materials in order to operate. So we were collecting up and disposing of all of the materials that are used by the medical community, radioactive materials used by the medical community, and things like smoke detectors that are essential to keeping us safe in our houses. And that I actually found that very interesting because it opened my eyes to just how dependent we were as a society on the products of the nuclear industry. And that's something I was going to talk about communications later, but something that I think we fail to remind people that the nuclear industry saves lives every day through what it does for the medical community and things like inspections of bridges and buildings that would not be as safe as they are today were it not for the products of the nuclear industry.
Yeah, absolutely. And I think that a big part of what we do focus on, speaking in terms of the public and not necessarily just people in the nuclear field, is the waste aspect of it and the decommissioning, because that kind of alerts us of potential danger and potential risks. So you yourself working in waste and decommissioning, what was the protocol for disposing of nuclear waste in the UK at the time? And what was sort of happening with decommissioning? Were you guys decommissioning at a rate greater than you were building new nuclear?
Wow. So you're asking me to stretch my memory. And when you get to my age, I tend to tell people if it didn't happen within the last 5 minutes or at least 35 years ago, then I have no chance of remembering it. So what was happening at the time? Well, so I was dealing with waste from outside of the, for a large part of the time, I was dealing with waste from outside of the nuclear industry. And a large part of what we were doing was actually decay storing. So many of them are hazardous for a short period of time, and you can reduce the hazard just by leaving them in a controlled way. But I think, when I talk to people about the waste issue, I think it's one of the things that we haven't learned to communicate effectively about. Waste is a bad thing, regardless of whether it's from the nuclear industry. Just simply the word implies something that you don't want. And then we build up a great deal of sort of a view that it's a hazard that's different to any other hazard mankind has managed. And that's simply not the case. One of the messages we need to be getting out to people about radioactive wastes, much like any other waste that mankind handles, is that, particularly the radioactive waste, when it's handled correctly, it's not a problem at all. So nobody in North America has been harmed by our management of used fuel from the reactor fleets. There's almost no other power producing industry that can state that. So from that point of view, it's not something that we should be hiding, but we should actually be proud of. And maybe a few other industries would like to follow our suit in our direction and put in the same sort of control over the wastes that they produce.
And I know that I'm pretty sure that in the UK right now, they're working on finding a geologic site to store the waste. In the US, we're having our own setbacks and actually getting one approved. In Canada, what's the current status of how you guys are storing your nuclear waste? Because you said, it's safe and it hasn't hurt anybody in North America. But I think when most people hear about waste, they think about sites like Hanford and the waste being stored, underground and leaking, or, certain nuclear plants where right now they're storing all of the waste on site because there isn't a place for long-term storage. So sort of how is waste storage progressing in Canada?
Well, and of course, everybody has seen The Simpsons, so that they know that nuclear waste is green and liquid and comes in barrels and routinely leaks out all over the place.
Right.
Which, of course, is not the case. In case anybody who is watching this doesn't realize that, the used fuel in Canada is stored in much the same way as it is in the United States. It's still on the sites It's in either in the ponds, still having the heat removed from it. When it's had its period in the ponds, it is moved into dry storage containers. The only difference is in Canada, our dry storage containers are kept inside buildings in a controlled atmosphere, whereas in the US they can be put outside. Our plan is much the same as the UK and the US, and that is to build a deep geologic repository. We have an organization, the Nuclear Waste Management Organization, who are endeavoring to find a socially acceptable site at this present time. And they have a long-term program for developing relationships with communities, establishing that it's with the community that they want to be host to the site, and also establishing that geologically it's an appropriate site to put it in. So that work is ongoing.
Yeah, and so I guess to, go completely out of order of how we structured this interview, to tie into communications, how do you communicate to a community, hey, we want to put nuclear waste in your backyard? Is that okay? How do you say that to somebody and get them to understand if there are any implications to that?
So I'm not an expert in that field, and the Nuclear Waste Management Organization are handling that at the moment. And I'm sure they'd be delighted to talk about it. But I have a more general philosophy. I don't deal with the actual communities, but I talk to people a lot about dealing with the radioactive waste problem. Not the particular communities, but people in general. And I think, and there are a few of us coming to this conclusion. There's a guy called Malcolm Grimston in the UK that also talks about this, that we have inadvertently scared people, and that we need to stop doing that. So I tell this story, and it relates back to being a materials scientist. Sometimes we scare people when we don't mean to. So as a material scientist, I knew that cracks grew in the skins of planes, and that the way that they used to deal with them was that when they grew long enough, they would drill a hole in either end of the crack and stop the crack from growing. Mm-hmm. And this is a true story. I sat in the plane one day and I looked out the window, and there was a decent sized crack with 2 drill holes in either end of it. And I thought to myself, that's great. I know this plane is properly inspected. I'm safe to fly on it. And I shared this information with the gentleman sitting next to me, who I had not met previously, and it turns out was scared of flying. And his view on the subject was very different to mine when he saw that crack in the skin of the plane. So, and everybody laughs at me when I tell that story, because how could I be that stupid? Well, I could, because I did. But we do that all of the time. So our response to, radioactive waste, it's the most horrible thing in the world, isn't it? Is to tell them about how we're going to put it in containers and put it deep underground and pack it with clay and do all of these things that are all very good things and will keep us safe. But we forget to tell people that it is no problem today, and that we're quite happily managing it on the surface, and it does no harm to anybody. And I think that's got to be a strong part of our communications. We've got to think about calibrating some of the challenges that we deal with into other challenges that are used elsewhere in the world. I used to, as I say, run radioactive isotope production facilities. Yeah. And we actually had a politician come round to one of them, and they're quite impressive. So you've got, hot cells and manipulators and, all of the feeling of stuff that is hazardous. And we're making the radioisotope for the physicians in the region. And a politician comes and he looks and he says, so, if you dropped one of those vials, what would happen? And I think he was thinking that, we'd have to close the facility down, and we'd have to close the university down, and we'd have to evacuate the region, because there was that kind of, radioactive fear in his eyes. And I just said, well, it would be a big problem, because clearly we had breached our procedures, because our procedures are designed to prevent that happening. But to calibrate the problem, we were going to inject it in someone. Right. And that's what, it brings a reality to how big a hazard that really was. Yes, you've got to protect your staff because they're doing it day in, day out. But at the end of the day, we were going to take that vial and we were going to put it in a syringe and inject it into someone. So it kind of, how much of a hazard is it really?
Right. And how did you, because you didn't, necessarily start off in the nuclear community, were you ever afraid of radiation or the nuclear sector? Or how did you overcome those myths that people are told?
So I realized the other day that I am actually still really afraid of radiation,
Interesting.
and for no good reason, right? I'm scared of a whole load of other things. I tell stories about calibrating my fear of radiation with my fear of going up the CN Tower. We have a very tall tower in Toronto with a glass plate in it, and as a material scientist, I know how strong the glass plate is, but I can't stand on it because I'm terrified of it. And it doesn't matter how much people explain to me that I shouldn't be terrified of it, that terror doesn't go away. So, in our communications, we need to understand that sometimes facts are not helpful because they don't take away the fear. But I think with radiation, working in the nuclear industry makes us fearful of it. And I suppose that's right in many ways. But I think we then pass that fear on in an inappropriate way to the public. Because as I say, I was doing something and I suddenly realized that I was incredibly fearful of radiation. And I knew all the facts and I knew that the levels that we were talking about were not anything that I should be fearful of. And that was part of getting a process that got me to thinking about, how are we communicating these issues? Do we actually inadvertently cause more problems than we solve when we talk about these issues?
Right. So you're saying that if we in the nuclear industry are less fearful of radiation and we express that to people outside of the industry, then, we directly from the inside can prevent other people from fearing nuclear power or nuclear for other uses, such as medical isotopes.
So I that's an interesting idea, but I didn't go as far as saying that. I got as far as saying that I think the way we communicate does confirm people's fears or build people's fears. I didn't say that if we appeared to be less fearful, that would be the solution. I think that's one of the questions that we need to be asking ourselves. And one of the things I was very pleased to be able to do in my last position was to bring the social scientists into the nuclear industry to start calibrating our not just a technical understanding of the way the world works, but a people-based understanding of the way the world works, so that we might start solving some of these problems. I think that the tendency within the nuclear industry has been that if only we could bend metal differently, then we would solve all of our problems. And I don't think that bending metal differently will solve the problems, because I think the problems are in the way that we deal with people and the way that we communicate with them. So not sure I have the right answer. I think I'm putting my finger on the right problems and looking at the people that do have the right answer to come and join the industry and help us with it.
Right. Get some outsourcing to help us market ourselves a little bit better.
Absolutely. Yeah.
So on the topic of marketing, one thing that I really wanted to talk to you about was the idea of selling SMRs as a product and as a fleet. And so sort of, what do you think is the best way that we could advance nuclear power SMRs the right direction? And if so, how do we actually start using them?
So I've been over the last couple of years, I've been very pleased to work with Bob Walker, who's also been on your Titans of Nuclear, previous president of AECL and another great proponent of SMRs. And he and I do a great team, make a great team, because he's been well entrenched in government, understand how government works. He's also a very clever person, and I'm not. So I create a balance to that team. But I've been very pleased to work with him. We've been looking at, we're not assigned to any particular technology or any particular program. So we've been independently doing a bit of think tank type work on the issues. And I think the first thing we tried to establish is that SMRs are a paradigm shift. This is not an extension of the conventional nuclear industry. There are a lot of changes, not just technological changes and not just changes in the size that come with SMRs, but there are other changes like the fact that they will be sold into different markets. It won't be government to government relations that has often happened in the past. It certainly won't be programmatic with much smaller projects and customers dealing with one-off situations. So the markets are going to be very different. We can't sell them as one-offs. They need to be part of a fleet. If you just have one SMR, then it's a demonstration of failure because all of the economics depend on you building lots of them and rolling them out in a fleet way. So we have to stop thinking about individual projects and start thinking about how we are going to make them work as a fleet. And I coined the phrase that we don't need to be looking at the first of a kind, the folk problem. We need to be looking at the Fadoke problem, the first dozen of a kind problem. And I don't know whether it's 12, but we certainly need to have a fleet mentality coming into the industry if we're going to develop SMRs successfully. And the final area is engagement. One of the analogies I give is that SMRs are like chickens, where the conventional plants were like dinosaurs. Dinosaurs tended to control their own environment. Chickens very much have to fit within the environment. And the reason I like the analogy so much is that chickens are actually effectively descendants of Tyrannosaurus rexes. Not direct, but fairly close in terms of the chain. So it makes quite a nice tie-up for the analogy.
Yeah.
But it also gets people thinking about the fact that we are dealing with very different beasts. And in dealing with them, you have to manage them in very different ways.
And what about the small modular reactors makes them inherently better as a fleet or only feasible through a fleet?
It solves one of the big problems of the nuclear industry of continuously building things for the first time and not being able to roll experience very effectively from one reactor to the other. Some programs have done that. The French did it. CANDU started to do it with its EC6s. But we never really consolidated on learning lessons on a particular technology type and moving forward from one project to the other. If we build lots of SMRs, then we will gain building experience and be able to drive the costs down. And that's going to be very, very important. So as we get through the first hump and get that first dozen of a kind up and operating, on the far side of it, things become much easier. But we do have to get over that kind of energy barrier to get the start of the fleet going. But I think, you asked about the things that we need to do to sell them. Well, one of the things that I'm very focused on is that it's not about selecting the right technology. We do need to do that, but it's more about making the markets want to buy the technology. And that's where governments and other organizations can do a lot of work to help sell SMRs by making people understand nuclear better, or helping people understand nuclear better, helping people see what benefits SMRs can bring in terms of economic benefits, but increasingly nowadays as a solution to avoiding greenhouse gases. And I use the analogy that you can pick the perfect seed, but if you plant it in a desert, it's going to die. But if you can make the ground fertile, you can plant almost anything and it will grow. So I think that a lot of the time we're looking the wrong way with SMR technology. We're looking at the technology where what we need to be doing is looking outwards to the people and to the markets and doing the work with those so that they are understanding and receptive of the SMR concept.
Yeah. What are some of the fertile markets you're seeing for SMRs right now?
Well, there's lots of people talking about them, not too many people acting on them. And I think that's partially because we haven't done the groundwork in making those markets fertile. So, one of the things I would very much like to see, and is starting to happen, and I think it's a signal that even the commercial markets want, is governments becoming supportive of new nuclear technology and incorporating them as part of their plans for greenhouse gas avoidance. And that, I think, would send a very positive signal to the markets. And we would start to see a lot more money flowing, a lot more positivity about getting them out there and getting them trialed and showing what they can do. So, and I think everybody in the industry has a role to play in helping people understand what opportunity that provides.
And so, do you think that by the government including new nuclear technologies like SMRs in their plans, that would almost be a signal to investors that it's safe to invest in it? Or why would that specifically help make it a fertile market?
I think it helps across the board if governments signal that is now in their plans. So I think you're right. It would give investors a lot of confidence, and that's a very important step in making the moves forward that we want to make. But it would also give the markets confidence that governments are going to go and talk to the people about why this is important and why it's included in their plans, and that helps anybody that's planning on incorporating SMR technology in their plans. It helps them feel confident that they're going to not get stopped further down by protests and complaints by people that haven't really understood what's going on.
Yeah, and I think that's interesting that you say that, because in my head, as you're saying, talking about the government basically communicating this to the people through putting it in their greenhouse emission reduction plans. In at least the US, I think a lot of people don't realize sort of that we already have nuclear power and that it is a big source of our clean energy. But we know like the government supports solar and wind, and those are sort of our ways to reducing greenhouse emissions. But I at least haven't imagined yet a world where communication about nuclear is so open to the public and is so open to opinions from the public. Do you think that making it, more visible to the public is going to increase support as long as we do it the right way? Or do you think that no matter how we communicate it, there'll be a little bit of a upheaval?
I think we have a harder challenge than wind and solar. I describe wind and solar as seductive technologies because people would like them to work. There's just something about them that seems somehow natural and appropriate. So they have a fairly easy ride. We have more of a challenge because people don't understand nuclear. They, as we were discussing earlier, they're fearful of some of the products of it. And so we start with a bigger challenge. But we also have a more realistic opportunity to deliver the solution that the world needs. Mm-hmm. And so, I think increasingly people are becoming aware that covering the world with wind and solar is harder than perhaps they originally thought, and requires a more extensive reach into nature than perhaps people had considered. And so they are casting around for other solutions. And nuclear power is one of those solutions. So I think as people become more aware of the issues, they will become more receptive to the technology. But we're going to have to work at it to help them understand that some of the fears, particularly those that were entrenched in the 50s, 60s, and 70s, and which, as we've discussed, I think the industry has gone on building on through the way it communicates. Some of those fears are unfounded, and people shouldn't be worried about them. Governments making statements about it would be very, very helpful in rolling that program forward.
What about somewhere, say Germany, where now their government is very openly not accepting of nuclear? How could somebody in Germany get nuclear back on the map? I'm going to challenge you.
Well, that's I hadn't actually thought about that one. I had kind of parked Germany as one of the countries that we would come back to later. I think probably it's a good idea to start in the easier places and roll forward there than, I think, I don't know the way that the Germans were thinking, but I think their views were very entrenched and it will take time to move them. I see, though, that they have no problems with using nuclear power that comes to them from France in order to shore up their system, and that those nuclear reactors are not very far away from them. So it's a very curious psychology that led them to do what they did. I think the solution for the nuclear industry is to prove its new products elsewhere, where people are more receptive, and then Germany will come round because it will become obvious to do so when it's been adopted elsewhere.
And now to bring it back to what you are an expert on yourself, what have you been doing with Bucephalus Consulting?
Well, I do a number of things with Bucephalus Consulting. I think basically going back to the sales concept that I outlined at the beginning, I find out what people want and then I do that for them. So, not all of my business is in the nuclear field. I do a lot of work on developing proposals and what I call compelling communications for people to help them sell things to other people. That's an area I find fascinating and everybody else seems to hate. So it's a wonderful business opportunity for me. Increasingly, though, I'm trying to position myself to help in creating that fertile ground for small modular reactors. It's the reason that I'm not doing that full time is people don't seem to want to spend money on that at the moment. And they do seem to want to spend money on bending metal. And I'm having a challenge convincing people that we need to be looking, at least spending some of our time, looking the other way and preparing the ground more effectively.
Is there a certain, dialogue that you frequently hear as to why people are against spending the money on it?
I don't hear a dialogue on it. My pet theory is that it's difficult, that a large number of people in the nuclear industry are physical scientists and engineers. We understand how bits of metal behave. We understand heat transfer and fluid flow. We understand neutronics, and they behave the correct way every time that we do it. People are different, and I think that that creates a challenge that sometimes we find it difficult. People are sometimes illogical. They, even when they know they're wrong, we begin to learn from modern psychology, what they will tend to do is dig in to demonstrate that they're right rather than admit that they're wrong. This creates challenges for us that we don't know how to deal with. And so I think that's one of the reasons people are reluctant to deal with it. So I think the other part of why there isn't as much attention being paid, perhaps to creating an environment in which SMRs can be successful, is that a lot of people think it's somebody else's responsibility to do it, and so there's lots of finger pointing to say, well, it should be the vendor, it should be the developer, it should be the person whose project it's going to be, it should be the government. And nobody can actually decide where that responsibility should lie. It's a challenging question. All I know is that if we're going to be successful, it needs to be done, and we need to find some way of doing it.
Right. So then on that note, as we wrap up, what is your opinion on who should be doing this, who should be moving the industry forward, and where we should be in the next 20 years?
Well, that's really obvious, isn't it? I think people should be paying me to do it. And I'm not worried who pays me.
It's a great answer.
No, that is a challenge. I think going back to the government role, I think increasingly they are going to find that to meet their greenhouse gas targets, they are going to have to invest in nuclear. They are going to have to see nuclear as part of their program. And so if they want to do that, then clearly they should be looking to create grounds in which they can successfully carry out such a program. So I think governments have a big role in the communications end of making SMRs successful.
Neil Alexander, thank you so much for joining me today.
Thank you. It was a pleasure. Enjoyed it very much.